Hi, I'm Takafumi Morita. I'm a PhD student at the University of Tokyo X-Labo. Today, I'm very excited to talk about our research paper named Design and Fabrication for Dynamic Color Changing on Curved 3D Printed Surfaces. Recently, various color changing interfaces have been proposed. Among them, changing the color of the objects with highly curved surface is challenging. Some methods using fluid or photochromic material have been proposed. However, this can result in bulky systems or require a long time for color changes. To address these challenges, we propose a novel dynamic and rapid color changing method designed for curved 3D printed surfaces as a self-contained system. The structure of this work is composed of 5 layers, with a heating paint curve ethern applied to the bottom layer. This arrangement allows heat to transfer from the back to the front. Carbon ethern is a highly efficient carbon-based electrically conductive heating paint. The heating temperature is determined by the Joule heat. The resistance value is determined as shown in this equation. By leveraging these characteristics, we explore a method to flexibly set the size and shape of the heating area to suit various applications. Fabrication is a 5-step process. First, we print a curved surface with a thickness of less than 1 mm. Next, the back surface of the 3D printed object undergoes pretreatment. Subsequently, we design and fabricate electrodes. The area where the electrode is to be placed is extracted from the curved surface data and developed into a planar surface data. The electrode is cut by a cutting plotter. Copper tape is adapted as the electrode material because it is easy to process. They are attached to the back surface of the object. Then, after thoroughly mixing, carboethan is applied. Insufficient mixing causes high resistance and inadequate heating. Finally, thermochromic ink is applied to the front surface. These are design examples. The duck shows color change on a highly curved surface. The butterfly shows color change on perforated surfaces. As a next step, we will further explore applications that could benefit from this work's contributions. Thank you.